All right, CS 1110, ready for round two. So before we start, I just want to say, check the link in the description for link to my exam one video, and this video will probably be broken up into several parts because my screen recorder is kind of awful. So yeah, if I don't forget, just check the links for those other videos. Okay. So first up on our list of fun, we have Boolean values and operators. So what are those? So a Boolean value is basically just something that evaluates to true or false. So we have the sentence Thomas Jefferson is a dolphin. That would end up being false. And my caps lock is on. Okay. So we have these literals for true and false with capital T and capital F. So we can just print true, and there we go. If I co-run, yeah. And again, don't worry that I'm not in PyCharm here. This is basically the same thing, just running from the command line. So yeah, so that just prints out true. So what if we print out false? Let's see, false. Oops, that's flas, false. Okay, then that should print out false. Good. And notice this is not a string. There's no quotes here. So if I type the lowercase false, it would say you can't do that because I'm looking for a variable called false and I'm not finding it. But capital F is going to be a keyword false, so it's actually printing that keyword false right there. Okay, nice. And why can't I get back to this? Uh-oh. There we go. So I think you got that, true or false. And then we have these operators too to work with them, and, or, and not. So what is something if it's not false? Well, it's true, right? So we can actually, hold on. Yeah, I just wanted to check real quick if this exclamation point works, which it does not. That is what Java does. But so in Python, the keyword is not. So something is not false, it's going to be true, right? All right. So then we have something of the idea of or. And what or does is if any side of the or is true, then it's going to, whole thing is going to evaluate to true. So true or false, that's going to be true, right? And then if we make true or true, obviously that's going to be true as well, right? So we got true there, good. And then if we do false or true, that's also going to be true. But the only way we can get this to be false is if we make both of them false, false and false, and that finally will be false. Why does this keep happening? Ugh. This box is being annoying. Okay, so next we have and what and does is it will only evaluate to be true if both sides are true. So I'm gonna run that, and yep, we got true. But if either of these is false, then all of a sudden it is false. All right. You can actually look up something called a truth table, which is what you're going to be working in probably next semester with, next semester with discrete math. And so, see, with and, if we have any combination where either of them is false, then we're going to get false. But if both of them are true, we're going to get true. And with or, we're going to get true for everything except if they're both false. So that's how they're kind of opposite there. And yeah. And by the way, this little V thing, that means or, but you don't have to worry about that yet. But we don't want to just do this with the words true and false. That's kind of, not very useful, right? So let's say we, instead of doing this, we're going to print, let's say we're going to say 5 is greater than 2. Is that true or false? It can be true, right? And I think, yep, parentheses. There we go. Yeah, 5 is greater than 2, so we're going to get true. And then, say we wanted to have that not 5 is greater than 2. Well, this is going to be true, right? So then we're going to get false because of the not, right? It's going to negate what's inside the parentheses, so we get false. And we could do, what else could we do? All right, I got a little practice problem for you. So try to figure out what this is going to print out. And here's a hint. It should take you about a second to look at it. All right, get it? You can pause the video if you want. But so what's going to happen here is, this looks nasty right here. Like, well, what's that? And not, what's all that? Python's going to read this from left to right, I believe. And over here we have or true. So when we have or with true, it means it's going to be true no matter what this is. We don't care. It could be true, it could be false, whatever. So this is going to be true, as you can see. Yep, true. Say they give you a problem on the test and they say, what's this going to print out? So give this a shot real quick. All right, got it. So the way you solve these is kind of try to like reduce it, sort of. So we're going to say 2 equals 3. Is that true? Oh, and remember, when you're comparing things with equals, remember if you're comparing them, it's going to be 2 equal signs, because if you do 2 equals 3, just quick aside here, it's not going to work because it's like you're trying to assign the value of 3 to 2, which doesn't make sense. Anyway, so yeah, we're going to say 2 equals 3, and that's false, right? So we can just put a false right here. And not false, well, then we can take this and we can go true. In order to go use the order operation, so go inside the parentheses and left to right. So then, and then 7 is less than 9. So that is going to be, wow, why is this so hard? Yes, it's true. And then, or 48 is greater than 49. That is false, right? So be false. So we have true and true or false. Okay, so now, yes, this is a little hard. So we're going to go from left to right, right? So true and true. So that's going to be true. We have true or false. Well, that just equals true. And there we go. And if you don't believe me, I can undo all that stuff I just did. And let's see, it's also true. Yes, cool. I just spent 5 minutes on Boolean values. I don't want to pound this into your head too hard, so I'm going to move on. So next up, I see test case selection and debugging strategies. So my guess is you probably have some kind of list within your lecture notes or something. Go ahead and study those. I'm not going to go over them. That's okay. But just in general, the test case selection, I usually want to look at something called the boundary cases, I think it is, and that's usually like stuff with 0 and 1 and like really big numbers and like try negative numbers, stuff that you think is probably going to make it fail, and it's boundary cases are going to be something like that. Usually 0 and 1 is something that's going to make it fail. And then debugging strategies, I usually just put a lot of print statements in there so I know what is going on each step. Like say I have this, pretend this is all like some kind of function or something, and so like I want to make sure this is running. So then I put a little print statement right here, make sure it's good there, and then I put a print statement here, make sure it's good there, and there's tons of print statements until I find out what is going wrong where. And yeah, so those are my debugging strategies. I'm sure you probably have some kind of list somewhere, so I'll go ahead and make sure you have the ones that you're actually given. Actually, just by doing a quick little Control F on their schedule, I see debugging techniques. You have a bunch of things here, so yes, take a look at those. All right, now we're on to while loops and for loops. So first, why do we even want loops? So let's say I want to print out to the screen hi 100 times. So all right, so let's go. Print, let's see, hi. Okay, that's 1. Okay, print, hi. Okay, that's 2. Okay, this is gonna take forever, right? So okay, so I'll copy and paste, right? Okay, copy, paste. Okay, well, okay, I gotta fix that. Okay, yeah, it gets crazy, right? So much easier way, we could just say for I in range and see. So you want to range up to 100, right? So range is gonna start at 0, 1, 2, 3, 4, 5. So let's just put in from 0 to 99 because you don't want to do 100 because it's starting at 0, so it's gonna have that extra one right there. And we're just gonna say print hi, and hopefully this works. Oh yeah, look, 100 highs. Look at that. Wow. So basically, so it's a way to make your code run like a bunch of times, which is very, very important in a lot of things. So first I'm going to explain what the for loop does. First, we're going to look at what is called a for each loop. You usually see for with range, right? But we can actually do something else where this will help you understand a little better. You might have done this in some of your homeworks too, where you say just for I in X, where X is like some kind of list or something, right? And it doesn't have to be X too. You can make, you can make this. You can make this like pizza. Pizza. We'd have to actually do it for both, but okay. So pizza. You can also change this one. You can make it let's say Tykonovich. You can basically name everything, and yes, I was checking to see if I spelled it right. So I'm just gonna change this back to the way it was to make things a little easier. So yeah, I just don't want people to get bogged down with naming an I every single time because it could be anything you want. It's up to you. So all right, so what is this doing? For I in X. So basically, we're saying I want to make a variable that's gonna be temporary within this for loop, and I want it to be called I, and I want I to be an item, a bunch of items in X. I want to take those values. So when the first time this is run, it's going to go, okay, what's inside of X? I have 3. Okay. And the next time it runs, it's going to use 5 as the I, and then 6 as the I. So it's going to take each value within X, and each time it runs, put it in I. So if we print this out, then we should get 3, 5, 6, 2, 5, because this is just being the I that's inside there. So if we print this out, and look, we got 3, 5, 6, all that stuff. So this is all the values in X that you're printing out. And then there's another way to do a for loop where we have for I in range, And how is that different? So basically, so what is range? So range is actually like this weird kind of thing in Python called an object. And you're going to be working with objects more when you get to Java, not so much with Python. So basically, you can kind of think of a range. I have this thing called pretend range here. It's basically like a list of numbers, just from 0 up to whatever you do. Or if you make it start at say 3 to 7, then it would be a list that looks like this, where it starts at 3 goes to 7, stuff like that. So basically, when you say for I in pretend range, you're basically doing the same thing we did up here with for I and x. But instead of doing 3, 5, 6, 2 is the I for each time it goes through the list, it's going to be 0, 1, 2, 3, all the way up through the list. So basically, you could go and make your own list if you want to do for I in range up to 1,000, make your own list going up to 1,000 and do that. But range is just a way to write it easier, and you don't have to make a list in Python and all that. So yeah. But be careful. Don't use list operations on range because it's not quite. You can actually change things in it. It's kind of like a big tuple, I guess. I don't know if you guys have learned tuples yet, but yeah. All right. So now we're gonna do for I in range 0 to 7. We're just gonna. Well, I'm gonna comment this out quick. We're gonna print I. So what is I gonna be? Well, it's gonna be 0, 1, 2, 3, 4, 5, 6, 7, right? Because this is basically what this is, right? So if I print this out, then there we go. So we got these values. And so sometimes you basically want to do the thing we were doing here, where we're printing out each value in a list. But we want to use this range here, and there could be various reasons for that. I'll let you think about that. But so the way to get that from there is we use the index of a list. And if you remember, I think I'm going to go over that at some point, probably with the word do list. But yeah, it's just x with brackets, and then you put the I inside the brackets, and it's going to say, all right. So say this is x of 5. And so what this is going to evaluate to is we're going to go over to x, we're going to look. And remember, computer numbers start at 0, right? So we're going to go 0, 1, 2, 3, 4, 5. So that's going to be 2. And actually, if I put this out, you get a whole bunch of 2s, right? Yeah, oh, wait, hold on. Yeah, error in my logic right there. So what this was doing is printing out the value in the range followed by the 2. So if you look, it's going to be a 2 every other one. But yeah, that's not really important. Okay. Why does it keep doing this? Anyway, I'm getting off track. So we do for I in range 0 to 7. We print that I. And we're going to have 0, 1, 2, 3, 4, 5, 6, 7. Sorry. Up to 6. Remember that. It's going to start at 0, so it's not going to include that last one. So, yeah, 0, 1, 2, 3, 4, 5, 6. Okay, so then we can actually use this I and use it as an index value to get stuff from x. So now we're going to get all these values from x. See? So yeah, then we got 3, 5, 6, 5. Oh, we stepped to 53 though. We wanted to go all the way to the end, but I mean that's a lot of numbers. I don't want to count all that. So what can we do? We can do from 0 to the len of x, and then now we're going to get all those. Last one's 3, and last one's 3. So there we go. And then well, this is also a lot of typing. Wow, it is 0 to x. Well, this is a cool shortcut of range. You can actually just put in one number. If you just do range of len of x, then this is just basically you're saying from 0 to that, but it's just a little shortcut. Get the same thing out. So yeah, and if you didn't want to include like the first 2 or something, then you could say I think it would be 2 to the len of x, so that would start at 6, I believe, if I'm not wrong. Yeah, starting at 6. So there we go. So just to reiterate, these two for loops do the exact same thing. So, well, how are they different? Well, we're saying for I in x, we're going to print out I. So for each value in x, print out that value, right? So yeah, we're going to print out I like pizza. And then this is doing the same thing. It's saying for I in this range from 0 to the length of x. So this is, let's see, 1, 2, 3. So we're going to go from 0 to 2, right? So 0, 1, 2. And we're going to look at the index values of x. So we're going to get x of 0 is going to be 1, or I, and then like pizza. So we should get I like pizza twice. And looks like that's what we got. So cool. So now we're on to while loops. So how while loops are different from for loops is they're going to run on basically on some kind of condition here. So if we have x equals 3, and it's going to say while x is still equal to 3, we're going to print out this array here. And what's fun about these is you can actually make your programs run forever. So if I run this, yeah, it's just going to print out hooray a whole bunch of times. If you want to see it like go insane, I can add a little. You'll learn this eventually. End equals that. And then let's see. Whoa, it's all over the place. Well, stop. Okay, yeah, so that's that. So you can think of a for loop as what they call a counted loop, where you kind of know how many times it's going to run, even if you're saying from 0 to the length of some unknown list. Like you know it's going to run up to the length of that unknown list. But while you're just saying you want to do it while this thing is true. So yeah. So you might not know how many times the while loop is going to run exactly, but it's going to run it while that thing is true. So let's say we have a variable called x equals x is 1, right? And we want to add 1 to x all the way up until hold on. Yeah, we want to add 1 to x until it equals 100. Um, and so why couldn't we use a for loop with this? Well, let's say we don't actually know the value of x, so x could be negative 999. We don't actually know, so let's just just for this we'll pretend it's 1. But so we use a for loop. We could say like, oh well, 100 times do it. Well, it could be negative 9 million, so it wouldn't work, right? So we just wanted to use a while loop here. So we're gonna run this, and yes, he's going to increment it, and that's going to stop when it equals 100. And why does it go to 100 and not like just a 99? Well, I said, well, x is less than 100. So when x equals 99, it's still going to have one more to do, and then it equals 100, and then it stops, right? So that's why that's why I got confused before. I thought it was going to stop at 99 or something. But yeah, so basically you're saying while, and then you put some kind of Boolean condition where x is less than 100, and then we're just adding 1 to x, and we're printing x. So this is the key concept. If you want your while loops to ever stop, you're going to want to change basically something within inside your Boolean thing. So like if I say y equals 1, and I say, well, y is less than 100, this is actually just going to run forever, right? Because C is going to 100, 200, and there's 300. Yeah, it's going forever because we actually never changed y. So I believe this is called a sentinel value, actually, where you set a value here and you're going to change it each time through the loop. And once it sees that this condition is now over, that's when you know to stop the loop. So now I know some of you are going to say, well, why can't I just use a break statement and you do this, right? So yes, this does work. See, it goes to 100 and stops, but it's sloppy, and you're better than that. So we're gonna go back. We're gonna put it the way it was with our sentinel value because trust me, it's a lot better. So yeah, we can run this, and then yep, and that's 100. So there we go. See, I'm going to move on if that's okay. If I don't explain something well enough, just feel free to leave a comment, and I'll see if I can get back to you with a more in-depth thing. I just don't want to be beating this into your head too hard. All right, so now we have collection types, and yeah, so basically what this is what I was showing before with the for each loop. So we can do this with looks like we have it's a list right here: string, list, and tuple, and range. So let's try it out. So first I have a x called hello, and I say for I in x, we're gonna print I. So what is this gonna print out? Yeah, so this is going to print out each character in X. So it's going to go H-E-L-L-L. So each time we go through, so I is H the first time, it prints H, so there's our H, and then it prints E, and then so on. So all right, so then next up we have a list here. And so now what's I going to be each time? Well, that's right, it's going to be each value within the list. So if we look at that, it's going to be my dog is bad at coding. My dog is bad at coding. So there we go. And then so now we can do it with tuples. And remember just want to make sure. Just want to make sure I'm getting the right information. A tuple is it is a yeah, the difference between tuples and lists are a tuple cannot be changed unlike lists, and tuples use parentheses instead of square brackets. Yep. So all right. So we can do this for a tuple too. And what do you think that's going to be each time we go through? Well, it's going to be each value in there. So did I get rid of my thing? Oh, there we go. Go, who's go. Good. And then the last one is range. And I just wanted to show you how you could do it differently here. Instead of saying for I in range, we can actually make X a range object, and we can just go for I in this X, which is a range object, and that'll work too. So yeah, there you go. And it's gonna be 5, 6, 7, 8, 9 because I said from 5 to 10, and it doesn't go all the way to 10. Remember, so yeah, that's it. There we go. All right, next up we have the basics of the dictionary data type. So if you go to my Quizlet deck, I'm S. Gatewood on Quizlet. And if you go to CS 1111 Spring 2017, I might be able to just put this URL in the description actually. But yeah, and then I have one on dictionaries. I just saw. Oh yeah, I put here. Yeah, I have a bunch of questions on here. I remember back in the day, I went through and made all these questions for it. Basically, how do I do the basics? All right, so basic. What is a dictionary? Well, dictionary, just like dictionary and like the Webster dictionary, you have it's basically a list of key value pairs. So you're going to have some kind of key, and it's going to correspond to some value. So these are really good if you want to link your data somehow. Yeah. So how you make something like this? I may try to make like a shopping list here, sort of. So basically, you make these, use these curly braces right here, and then you can write out like I want to see one is eggs, and let's see, and then two is I'll say milk, and then three, what else are we buying? Let's buy Oreos, right? So Oreos, yes, and yeah, so that's how you make your dictionary right there. And alternatively, if you don't want to do that, or if you want to add something later or something like that, so the way to make an empty dictionary is we can just make an empty dictionary here, and then so make sure. Yeah, so then how we can add to this dictionary is we say d of 1 equals, and we're going to say, what was it, milk, and then d2 equals eggs, and then d3 equals Oreos, was it? Yes, or Oreos. I'm gonna keep that. I like that. Okay, and then so if I print this out, we're gonna get something that looks like this. So I'm gonna show you what this does in a minute, but so yeah, first we're just gonna print out the dictionary. Let's see what that looks like. So I'm just gonna get rid of this real quick. Then so we're gonna get 1 is milk, 2 is eggs, 3 is Oreos. Okay, and then so I go back. Yeah, so I was gonna show you if we print out d dot values with 2 parentheses after, because this is actually a method of the dictionary object, I believe. So if we print that out, what do we get? So I'm actually gonna get. Wait, I didn't save. Yes, there we go. Stop. So we're gonna get this thing called, it's gonna say dict values and then milk, eggs, Oreos. So what this actually is, if we go get a little type real quick, see what data type that is. We can see it's gonna say, whoops, it's gonna say class dict values. But if we want to make this a list or something, because that's usually more useful for what we're doing, yeah, we can use this list keyword right here to coerce it to a list. Now we have this list of all the values we have, and then we can also do the list of all the keys we have. So it's going to be 1, 2, and 3. Another cool thing is I kind of follow this pattern of like where we had an integer and then like some string, but we certainly don't have to do that. We can make this like over here. We can make it like this, and then we can make this one like I'm gonna make it Oreos because I like that. I want a dinosaur to be called Oreo at some point. And then we can let's see. I'm gonna make a dictionary called X. I'm gonna be empty, and I'm gonna give a dictionary. So there you go. And yeah, put this out. It should still work. Um, yeah, so we have let's see, we have 1 is 3.3, Oreos is eggs, and 3 is an empty dictionary. Yeah, so you can mix up the types. The only thing is you cannot. There are two rules I think that you can't break. There might be more. If you find more, leave one in the comment. But yeah, so you can't make a key a dictionary. You see, we could make the value, but if we make a key there, then we're gonna get this unhashable type error right there. Yeah, right there. And then another thing is if we make X a list, that won't work. So yeah, it's also unhashable type. And then if we make it a tuple though, I think that works. Works just fine. So a tuple, empty tuple equals 2.3, all that stuff. So yeah, but you can mix up the types. You don't have to like have all the keys be one type and all the values of different types. You can mix them up. See, yeah. I wanted to do an experiment to be crazy. I wanted to see if I can make one of the values the dictionary itself, and I got this weird output. Yeah, this is eggs. I guess this is just saying like it's just itself over and over again. Yeah, so cool. I guess I can just go through a few of these questions. So what's called dict is it ordered? No. Can you have duplicate keys? No, you can have duplicate values though, but not duplicate keys. And let's see, dictionaries are mutable. I think what that means is just if you actually change the dictionary, it's going to change the exact one inside your computer. And so when we say something like, yeah, so if we have a list here and we see that we have list and dict and set are all immutable, the others are immutable. So dictionaries are mutable. And what that means is, I believe it means if you go and change it, it's going to actually change the one in memory. But if you go and change like an integer or something, so if you have like x equals 4, and then you're going to redefine it as x equals 5. What it's actually doing is it's making a new integer in memory called 5, and then or it's called x, and it's going to reassign it to 5. The 4 still exists, but it's just no longer called x, and it'll probably be picked up by what is called the Python garbage compiler, or the garbage collector. I think that's it. Yeah, if that's horribly wrong, let me know. So can you say make one of the keys a tuple, one of them a boolean, etc.? Yes, you can make them. They're heterogeneous. So as I showed you, you can do like all the different things here. So and then how would you have a user add to a dictionary? You'd have them put in a key and a value, and then just set the x key equals value. And then yeah, if you index a dictionary and there's no key there, you're gonna get key area. I don't think you have to know that. Can dictionary be a key in a dictionary? No, a dictionary cannot be a key, but it can be a value. So you can use this in operator with dictionaries. So if you want to see if 5 is in the dictionary, I think that yeah, it's for keys. You can see if I check it like this. We can use the in operator to see if the values in the dictionary. Nope, I don't think that works. And then how does length work? It's going to return the number of keys in dictionary. So basically the length of this keys list that you have. And then so what is I don't know if you did this, but dictionary.pop that takes a value from the dictionary and actually deletes it from the dictionary, but it returns it too. So I'm show you that. We have a dictionary here where one is hello, 2 is there, 3 is boy. If we print that out, then we're going to get this hello there boy, right? And then so then if we pop 1, what is 1 going to be? It's going to be 0, 1? No, it's going to be the key 1, right? So it's going to print out hello here, as because that's what it's going to get from pop. But also it's going to delete from the dictionary. So then we should just see there boy after that. So yeah, so we have the original dictionary there, and then so we pop to 1. So we take the value of hello and we return it to the print statement, and then we delete it from that